Local area networks are a type of networks which are composed of several equipment, which might be of different types, that share the same medium to communicate. In principle, local area networks are composed of various hosts or peripherals, which are generally very simple hardware, and which communicate with one another using means of communication or medium of communication, and transmit typically broadcast messages. In fact, the channels at the physical layer are broadcast channels. However, as each of these equipments are identified by unique identifiers, then there is also a mechanism of addressing which allows each equipment to identify and decide whether the message was intended for them or not. Now, depending on the technology, there are also different types of local area networks that we can identify. The main body of standardization for local area networks is IEEE. And depending on the technology which is used, we can identify several different types of, let's say, LAN communication technologies. The working group which takes care of local area networks is the IEEE 802 project or working group. What is important to emphasize is that the LLC, which refers to the logical link control, and the higher layers like the IP, the transport protocol that we've seen in other videos, are the same regardless of the LAN technology which is used. However, the differentiation comes when we talk about the MAC layer and the physical layer, because we might be dealing with different types of wireless or Ethernet communication. In fact, in the following, we will go and see some of these technologies. Ethernet is one of these LAN technologies. It is often referred to as IEEE 802.3. What is characteristic is that it's a technology that has evolved across several decades. It implies the existence of various end hosts or equipment, computers in this case, that share some medium in order to communicate with one another. Here, we've identified several of the main components. Initially, the physical medium that was used, it was a coaxial cable in which the stations were connected. In today's world and more recently, the communication is done using this type of star topologies as the one which is shown here, in which the central component is a given equipment. Such equipment can be a hub or it can be a switch, as we will see in the next slide. The communication or the connection of the end hosts, in this case of the computers, is done by using twisted pairs and typically using a standard of the plugs such as RJ45, which is also shown here. Now, when we talk about Ethernet, we are always referring to the data link layer. Data link layer implies that the type of messages which are transmitted are frames, while in the IP layer, the type of messages are packets. The type of messages which are exchanged in the data link layer are frames. Here we see a format of the frame composed of different, let's say, units of information. We have the preamble, which is composed of 7 bytes, which basically is used for physical layer synchronization. Then there is the frame delimiter, which is equal to 1 byte. And then there are the destination address and the source address. Again, here we are referring to the data link layer. So this is the destination address and the source address of the frame pertaining to the data link layer. And these are equal to 6 bytes each. Then we have the type length, and we have the main payload, which is the main message to be to be transmitted, basically. Then there are other information such as the padding or the frame check sequence. As in previous protocols that we've seen, frame check sequence has a specific task, a specific role for doing some sort of error checking. What is important to emphasize is when we talk about the frame, the maximum length is equal to 1,500 bytes. MTU stands for maximum transmission unit. Now let's focus, or looking at this frame, let's focus more on the destination address and the source address. What does it mean to do addressing when we talk about the data link layer? While MAC addresses are 6-byte addresses, this implies again that the 3 bytes identify the manufacturer and the 3 bytes identify the card. In fact, we see the notation here, which is slightly different to the one below. The main reason is because in practice, the way how we represent the MAC addresses is through hexadecimal notation. This implies that each symbol, each character, is representing 4 bits. Therefore, the type of representation that we see is here. But this representation, in fact, can be mapped very easily to a bit representation in which each of these symbols represents the 4 bits. The same how we have a different type of messages in the IP layer, we also have this in the data link layer. One type of message is the broadcast message, which implies that the message should be sent to all the hosts, all the equipment, which are connected to the local area networks. This implies that the MAC address is, the bits are set equal to 1. So in terms of hexadecimal notation, what we will see is a sequence of F notations which amounts to 48 bits. In fact, depending on the type of the equipment that we have, also the communication might differ. In practice, there are 2 main equipment that we can identify when we talk about the data link layer, the hub and the switch. Hub is a very simple equipment which basically replicates whatever message that it receives. Here we see a network of 3 hubs connected to one another, and we see that on the bottom part each of the hubs is connected to 3 hosts. Let us assume that we have a message which goes from A towards D. The logic or the way how the message are forwarded, considering that hub in reality all that it does, it replicates the message in all of the ports besides the incoming port. So the message, in this case the frame, will arrive from host A towards the hub. The moment that the hub receives the message, what it does is that it forwards the same message in all of the other interfaces. So it will send the same message towards the hub on the upper part, and also will send the same message towards B and C. Since there are addresses pertaining to B and C and mechanisms through which B and C can check if the intended frame, if the intended message is for them or not, then if there is no match, both in terms of the MAC address or even in terms of the IP address, since hosts in fact operate up to layer 3, then B and C will discard this message. On the other side, the hub on the top part, what it does is that the message which it has received, it will forward it through all of the other interfaces. So it will forward it through the interface that connects to the hub on the right part. In the same way, the hub on the right part will forward the message towards D, towards E, and towards F. Since the frame is intended to D, then we will notice that there is a match in the MAC address of D on the frame, on the message that the A has sent. So the message, the frame will receive its destination. However, similarly to what B and C acted, the hosts on the other side, so E and F, that are again in the same local area network, will discard the message which is received because the MAC address of the destination does not match their MAC address. Now, this is the functionality of the hub. The switch, on the other hand, has slightly significant difference because it analyzes the MAC addresses. So it creates what is known as the MAC table, in which it does a mapping of the MAC address and the ports that it has. So in this case, we see a switch which has 5 ports. And what it does a mapping of the MAC addresses of the messages that it receives with the corresponding port. Let's check the same message again, in which host A sends a message frame towards host D. Host A is characterized by its local MAC address, which would be MAC address A, for example, and the host D in a similar way, MAC address D. So when the message is sent, the frame, in this case, since we are talking about the data link layer, has as the source MAC address A, and the destination address as the MAC address D. When the message, in this case from A, has reached the switch does not behave in the same way as the hub that was flooding or forwarding the same message in all of the interfaces. If the switch has known or has knowledge of which equipment are connected to which of the interfaces, then what it does is that it forwards the message directly towards host D, because it knows that that is the intended destination for that message. Now, depending on the state of the network, there are a series of protocols and type of messages that allow for the switch to do, let's say, the discovery of the equipment with which it is connected. We will see later on the use of ARP protocol, which in fact serves as the protocol through which equipment discover what are the equipments in the local area networks. We can assume that at the very start, when we connect the local area network, there is a need for an exchange of messages through which the switch will learn what are the MAC addresses of the equipment in its local area network and with which of its interfaces are such equipment connected to.